Hello students, today in this session we will discuss the reactions of carbonyl compounds with ammonia derivatives. Ammonia derivatives means compounds derived from ammonia. All of you know NH3 ammonia. These are derived from ammonia, that is obtained by replacing hydrogen atom of ammonia, one of the hydrogen atom of ammonia with any group. In general I say A. Please try to understand. When hydrogen atom of ammonia is replaced by A, we got NH2A. NH2A. Now what will happen? This ammonia derivative undergo reaction with water. We call nucleophilic addition reaction followed by loss of water. It is common. Elimination of water as byproduct takes place in these reactions. Now we will proceed these reactions one by one. At first, that's the general reaction. Try to understand. Please, it is carbonyl compound, maybe aldehyde or ketone. Now it is not ammonia, it is ammonia derivative because it is derived from ammonia. We substitute one of the hydrogen of ammonia with A. What will happen in these reactions, students? Water is eliminated as byproduct. It means it is clear. Carbonyl carbon will lose oxygen and ammonia derivative, it will lose hydrogen. And what will happen? Carbonyl carbon form double bond with nitrogen atom of ammonia derivative. The product is common in all reactions, that is. Now it will form double bond junction with nitrogen atom of ammonia derivative. It means for this reaction, what is the product? C double bond Na. These are the reactions of carbonyl compounds with ammonia derivatives takes place in weakly acidic medium. Loss of water takes place. Now students, A may be OH. A may be OH. If A is OH, it means the compound is NH2OH. That is hydroxyl amine. NH2OH hydroxyl amine. A may be NH2, it means the compound is NH2NH2, or you can say N2H4, that is hydrazine. N2H4 hydrazine. Next, A may be NHC6H5. It means the compound is NH2A. A is NHC6H5. Students, what we call to this compound? Hydrazine. One hydrogen is replaced by phenyl group. It means its name is phenylhydrazine. What's the name of this compound? Phenylhydrazine. It is hydrazine, NH2NH2. Nitrogen show catenation in this compound. Next, students, at last, A may be NHCONH2. It means the compound is NH2 NHCONH2. This is called semicarbazide. We will discuss the reactions of carbonyl compounds with these four ammonia derivatives, that is hydroxyl amine, hydrazine, phenylhydrazine and semicarbazide. Please at first you should know the formulas of these compounds. It is clear: hydroxyl amine containing hydroxyl group as well as amino group NH2OH. Hydrazine NH2NH2. Phenylhydrazine, one H is replaced by phenyl group. Last one is semicarbazide. Now we will discuss the chemistry of these reactions one by one. Now students, question may be complete the reactions. Now it is clear these are the carbonyl compounds: acetaldehyde, benzaldehyde, acetone, and these are the ammonia derivatives. NH2OH, hydroxyl amine, hydrazine, hydroxyl amine, it is phenylhydrazine and so on. We will discuss their chemistry one by one. Complete the reactions, or question may be give chemical equation for the reaction of acetaldehyde with hydroxyl amine. Then you have to write reactant. Give chemical equation for the reaction of acetaldehyde with hydroxyl amine. What will happen, students? Carbon atom of carbonyl group participate, it will lose oxygen, and ammonia derivative, it will lose hydrogen atoms. That is, water is eliminated as byproduct. Now students, what is left? It is clear: CH3CH. Now carbonyl carbon will form double bond. Be careful. Now it will form double bond with nitrogen because nitrogen lost two monovalent hydrogen and carbonyl carbon loss one divalent oxygen atom. What is the product? It is clear. CH3CH, double bond junction between carbonyl carbon and nitrogen, that is the product. Definitely you will got 1 marks. Complete the reactions. Very easy all. Only you should know the name of these compounds. Second one, students, reaction of benzaldehyde with hydrazine. Again it is common. Carbonyl carbon it will lose oxygen and ammonia derivative it will lose hydrogen atoms. What is happens, students? Water is eliminated as byproduct. Students, what is left? It is clear. C6H5CH. Now this carbonyl carbon form double bond with nitrogen atom of ammonia derivative. That's the right product. After this, students, next there's the reaction of acetone with hydroxyl. Students, what will happen? Carbonyl carbon will lose oxygen and ammonia derivative will lose hydrogen, that is water is lost as byproduct. Now we have to mention products. Students, be careful. If it is acetone, carbonyl carbon will participate, alkyl group will not participate, they are inert, they will remain as substituent groups, that is mention them in side chain. They are substituent groups. Carbonyl carbon it will form double bond with nitrogen atom of ammonia derivative, double bond and OH. If you understood this, then that's your assignment. Complete these all reactions, students. There's again the reaction of acetone with phenylhydrazine, acetaldehyde with semicarbazide, benzaldehyde with again phenylhydrazine. Carbonyl carbon will lose oxygen and ammonia derivative will lose hydrogen atoms. I'm sure you can easily complete these all reactions. After this, students, there is also one question in NCERT. Why does reactions of carbonyl compounds with ammonia derivatives takes place in weakly acidic medium? This whole reaction proceeds in weakly acidic medium. pH must be 4 to 5. These reactions takes place in weakly acidic medium because in strongly acidic medium, what will happen? If it is strongly acidic medium pH 1 or 2, it will attack on lone pair of nitrogen. When it attack on lone pair of nitrogen, what is formed? NH3A, and nitrogen will acquire positive charge. It means now it does not exist as nucleophile. We say nucleophilic addition reactions. Because in strongly acidic medium, that's the answer, nitrogen atom of ammonia derivatives gets protonated and it becomes weak nucleophile. Please do this question in your notebook. Why does nucleophilic addition reaction of ammonia derivatives takes place in weakly acidic medium? In strongly acidic medium, nitrogen atom of ammonia derivatives gets protonated and it becomes weak nucleophile. Students, after this, next is reduction reactions. Reduction reaction. Reduction means higher functional group reduced to lower functional group. Reduction reactions. We will discuss these reactions. Before this, at first there is some questions in NCERT. Give chemical equations for the reactions of acetone with acetone, students, propanone with number 1 hydrazine. I'm sure you know the formula of hydrazine now. Hydrazine is N2H4, that is NH2 NH2. We have to give chemical equation. This reaction proceed in weakly acidic medium. Please try to complete by yourself. It is clear. Oxygen atom of carbonyl group participate and hydrogen atoms of ammonia derivative participate. Loss of water takes place and double bond is formed between carbonyl carbon and nitrogen. Let's I'm going to complete. CH3 C CH3. Students, alkyl group will not participate, it is inert. Carbonyl carbon will form double bond with nitrogen atom of ammonia derivative, the rest is as such NH2 plus water. Now second, it is new for you, 2,4-DNP. It is hydrazine, it is 2,4-dinitrophenylhydrazine. Please write the full form. 2,4 are the positions occupied by nitro group. 2,4-dinitrophenylhydrazine. We have to keep the chemistry of acetone with 2,4-DNP. Now acetone, it is clear to you. CH3O, propanone with 2,4-DNP. 2,4 are the positions occupied by nitro group. 2 times means dinitrophenylhydrazine. It is its full form. 2,4-dinitrophenylhydrazine. Please at first try to proceed for hydrazine. What is hydrazine? All of you know? NH2NH2. It is hydrazine. Now phenylhydrazine, that is hydrogen atom of hydrazine is replaced by phenyl group. Hydrogen atom of phenyl group is replaced by phenyl group. It is phenylhydrazine, NH2NH C6H5. Now we have to mention substituent at second and fourth position, dinitro. Students, that's the already position occupied. First position it is second, NO2, and fourth position NO2. That's the compound 2,4-DNP. It is also ammonia derivative. Common reaction, students, weakly acidic medium. You can easily complete. Clear? Carbonyl carbon will lose oxygen and ammonia derivative will lose hydrogen. There is double bond between carbonyl carbon and nitrogen. 2,4-DNP, you should know 2,4 are the positions occupied by dinitro groups and P stands for phenylhydrazine. At first approach to hydrazine NH2NH2, then replace one H with phenyl group, it is phenylhydrazine. Second and fourth positions, they are occupied by NO2 group. We call it 2,4-dinitrophenylhydrazine. You can easily complete it. That's assignment for you, students. Complete it. I'm sure you can do. After this, next, students, reduction reactions. I already clear reduction means higher functional group reduced to lower. We have to proceed backward. And in oxidation, we have to proceed forward. Lower functional group oxidized to higher. It is oxidation. And reduction means higher functional group reduced to lower. Complete reduction and incomplete reduction. Students, complete reduction, that is reduction to alkanes. We got alkane as the product. We will discuss these reactions one by one. At first, complete reduction reactions, it is clear what is product alkane. It means it becomes easy for us. Product will be alkane. And in incomplete reduction, that is reduction to alcohols. Organic chemistry starts from hydrocarbons, that is alkanes. Complete reduction, that is carbonyl compounds, they are reduced to alkanes. And incomplete, they are reduced to alcohols. Now we will discuss the chemistry one by one. At first, complete reduction reactions, students. It is clear in these reactions, the product is alkane. If it is ethanol, we got ethane. It is propanol, we got propane. If it is propanone, again we got propane. Complete reduction first is with zinc amalgam and concentrated hydrochloric acid. Amalgam, when one metal in alloy is mercury, we call it amalgam. Zinc amalgam and concentrated hydrochloric acid. Students, it is naming reaction. Important, we call it Clemenson's reduction reaction. Clemenson's reduction reaction. Which substance acts as reducing agent? Zinc amalgam and concentrated HCl. You know, in Rosenmann's reduction reaction, the reducing agent is, in Rosenmann's reduction reaction, catalytic hydrogenation, and we use PD plus BaSO4. Aldehydes were prepared in this. But it is reaction of aldehydes. Complete reduction. Clemenson's reduction reaction. It is naming reaction. You will write in this reaction carbonyl compounds are reduced to alkane. या फिर carbonyl compounds are reduced to alkane when treated with zinc amalgam and concentrated HCl. It will supply nascent hydrogen. You must have to write this reagent on the arrow for Clemenson's reduction reaction. Otherwise it is invalid. Zinc amalgam and concentrated HCl. What will happen, students? Zinc undergo reaction with HCl in mercury, leads to a formation of salt and will supply nascent hydrogen to carbonyl compound, and it is reduced to alkane. What is its function? To supply nascent hydrogen. It's not mandatory to write nascent hydrogen, but it's mandatory to write reducing agent. What will happen? Complete reduction, students. Complete reduction means carbonyl carbon will lose oxygen. When it loses oxygen, you know it is divalent. It means two monovalent hydrogen atoms will join to carbonyl carbon. When two monovalent hydrogen atoms join to carbonyl carbon, it is clear what is product. CH3, CH3, ethane. Oxygen undergo reduction, that is water. Clear? Reduction. Complete, that is reduction to alkanes. I think it's supply nascent hydrogen, stoichiometry 4. Again students, it is mentioned on the arrow, it is carbonyl compound, acetone. It is clear zinc amalgam and concentrated HCl, complete reduction reaction takes place. Complete reduction means total elimination of oxygen from carbonyl compound. And nascent hydrogen will join to this. It is clear it is divalent. Two nascent hydrogen strike on this carbonyl carbon, CH3, CH2, CH3. That is propane is obtained. CH3, CH2, CH3 plus water. You have to mention any equation students. Please try to complete these reactions. It is mentioned, it is carbonyl compound. I write RR. Zinc amalgam and concentrated HCl. Again it is Clemenson's reduction. Do it in aromatic compound. C6H5CO CH3 acetophenone. Clemenson's reduction. What is the condition? Zinc amalgam and concentrated HCl. Students, what will happen? Carbonyl carbon will lose oxygen and it will gain nascent hydrogens from reducing zinc. Clear? Ethyl benzene is formed. Please complete. That's again assignment. After this students, next second is with hydrazine and QH. First we do with zinc amalgam and concentrated HCl, Clemenson's reduction reaction. Second is with hydrazine and QH. It is again naming reaction, Wolff-Kishner reduction reaction. Again in Wolff-Kishner reduction reaction, carbonyl compounds they are reduced to alkane when treated with hydrazine and QH. That is reaction proceed in two steps. First step we have already discussed. Hydrazine and QH, what will happen? Carbonyl carbon will lose oxygen and ammonia derivative will lose hydrogen. In first step we treat it with hydrazine. You know hydrazine and H2NH2. Students, what is formed? CH3CH double bond and NH2. Hydrazone is formed. What is lost as byproduct? Now when we treat this hydrazone with QH, students, nitrogen gas escape from this. Nitrogen escape means it is clear N2 and this hydrogen H2 strike on unsaturated carbon. When these two hydrogens strike on this unsaturated carbon, it is clear what is product? CH3, CH3. It is Wolff-Kishner reduction reaction. Proceed in two steps. Please try to proceed in this. Hydrazine and QH. It is clear student, it is propanone. It is complete reduction. We got propane. Next with HI in the presence of red phosphorus. Students, whenever we use HI, it is strong reducing agent. Compound may be carbonyl compound, compound may be acid, compound may be alcohol. All time, remember the product is alkane. Having same carbon as in organic compound. 2 carbon means ethane, 3 carbon means propane, again 2 carbon means ethane. It is strong reducing agent, HI. In P block we have studied HI is strong reducing agent. Ethanol, definitely we got ethane. Propanone, definitely we got propane. Ethanoic acid, we got ethane. HI in red phosphorus, students. Oxygen loss, oxygen undergo reduction, we got water. Plus HI reduces other substance but itself is oxidized. It eliminates in the form of I2. If we have to balance, we can easily balance. There are total 4 hydrogen atoms. 2 strike on carbonyl carbon and 2 strike on oxygen. That is 4. 2I2. That is a stoichiometry of product. But no need to balance. Again we got water plus I2. You must know whenever we treat any compound with HI in red phosphorus, the compound is alkane. It is ethanoic acid. Students, again same. Oxygen undergo reduction. We got water and HI reducing agent reduces the other substance but itself is oxidized from molecular iode. It is clear there are 2 oxygen atoms. It means twice 2 to the 4. 4 hydrogen strike on oxygen and 2 on carbonyl carbon 6 strike. So it is 6 times. It means iodine we have to balance. We will write 3I2. That's the complete reduction reaction, students. Proceed with number 1, zinc amalgam, concentrated HCl, Clemenson's reduction reaction, any carbonyl compound, give alkane. Hydrazine and QH, Wolff-Kishner reduction reaction, again we got alkane. That is third, it is not naming reaction, general reaction we got alkane. Please do up to this. Thank you.